Okay, in this lesson we're going to go over a few applications of derivatives. We already know that slope is the rate of change, and in the context of distance and rate and times, we know that we have this formula d equals r times t, and if I were to solve that for r, then it would be d divided by t, okay? And in the context of what we're going to talk about right now, this is velocity, okay? Speed with a direction, velocity. Alright, so your average velocity, that sounds like average rate of change, that's AROC. This is a slope. Okay, so we're going to do some distance minus some distance over some time minus some time. This looks a lot like the slope formula for a reason. It is the exact same thing. So when we look at this problem with the billiard ball, we have a billiard ball that's dropped from a height of 100 feet, and you can see the 100 right there. That's the initial position. The negative 16 has to do with gravity, but overall, this equation right here tells us about the height, or in general, the position of this ball. Okay, so to find the average velocity, we are going to do a difference quotient. We're going to take the position at the second time minus the position at the first time divided by the difference of these two. This right here, College Board very much wants to see this step. I don't care if you know it, you can do that in your head, you actually have to show that. So we got to come over here and actually find S of 2 and S of 1. Well, this is just plugging the value in for t right there. So when you do that for S of 2, you get 36 feet. That's how high the ball is after 2 seconds. When you do this for 1, you get 84 feet. Okay, so now we're going to actually solve this difference quotient, and so that's going to be 36 minus 84 over 2 minus 1. That turns out to be negative 48, and since this is velocity, we're going to put in our units feet per second. Don't automatically put meters per second. You got to look at what units you're in. Now, as opposed to average velocity, instantaneous velocity, we are going to need to do calculus. This is IROC. This is instantaneous rate of change, which means we need to do a derivative. So this is a very small interval. So we could use the limit definition, but we are just going to go ahead and use the derivative instead because we've practiced that. So it's the derivative of the position. So use the power rule. 2 times negative 16 is negative 32t, and then your power b1, and derivative of 100 is 0. Okay, so this right here is our instantaneous velocity. It depends on time, and it's going to change with time, so that's why we have an expression. If I wanted to find the instantaneous velocity at a time, say at time 2, we would now plug 2 into my new equation, and that would give me negative 64 feet per second. Okay, so in general, the instantaneous velocity is the derivative of the position function. Alright, and just how this relates back to speed, speed is the absolute value of velocity. And we have this overall equation right here where the position is half of gravity, where gravity is 32 feet, that should be per second squared, or in meters, meters per second squared, negative 9.8. So we have that. V sub 0, or V naught, is initial velocity, and S sub 0 is initial height. Now, a lot of times these will already be given to you in the equation. Sometimes you will have to come up with the equation yourself. So looking at this example, they already give us this position, and it's a diver jumping off a diving board. And so we have this diving board. The diver jumps off and then hits the water. That's somewhere below that diving board. So 32 feet above the water, that's our initial position, and they already put that in. Alright, this 16 right here, this middle one, that's the initial velocity. That's the velocity at which the diver jumps up. Okay? And this negative 16 at the front is from half of gravity. So this is a when. I like to read the question mark because that tells me what I'm trying to find. I'm trying to find time. When does she hit the water? So we know that when she hits the water, her position is equal to 0. So we're going to set that whole equation equal to 0. Now you can try to solve this without a calculator. That's totally fine. You could do factoring or quadratic formula, and you can definitely solve it in your calculator. When you solve it in your calculator, you end up getting t equals negative 1 and t equals 2, and negative 1 doesn't make any sense, so I'm going to scratch it out because negative time doesn't really make sense. So there's our answer right there at 2 seconds. All right, so then we get to the next one. What is her velocity? So we're trying to find velocity on impact. So we know that impact happens at 2 seconds. So we need to find the velocity. Now, when they don't say average or instantaneous, it implies instantaneous. So this means we need to first just find the velocity. Using power rule, I'm going to take the derivative. Let me write that in. So it's going to be negative 32t plus 16. And then that happens at 2 seconds, so I'm going to find velocity at 2 seconds by plugging 2 in. And so that ends up being negative 48 feet per second. And that's your answer for that question. Okay, then we get to when. Again, we're trying to find t. When is the velocity equal to 0? So I'm going to use my velocity equation again, and I'm going to set it equal to 0. So negative 32t plus 16 equals 0. Now this you could do without a calculator. You end up getting 0.5, and we need to put units on there, seconds. You could use a calculator if you wanted to, though. That would be okay. All right, last one. What is her velocity? So trying to find velocity at 1 second. So this is just what is v of 1? Okay, so v of 1, going back to our velocity expression right here, negative 32 times 1 plus 16, that's negative 16 feet per second. 1.5, we would do the same way. And hopefully it makes sense that these velocities are negative, because this is when the diver is going down. All right, and that 0.5 seconds, by the way, is happening right there. The velocity equals 0 when the diver is going to be at the maximum. Okay, let's look on the back. I'm not going to spend a lot of time on this, but you can do, we've been doing first derivative. Second derivative is going to pop up, and then third and fourth and so on. Those are going to be pretty rare. But all you're doing is taking the derivative over and over again, and all of this up here just shows the notation of how you'd write that. So let me just show you. If I ask you to find the third derivative, just first find the first derivative. 6 times 5 would be 30. X, you subtract 1 from the power. All right, minus 3 times the derivative of sine is cosine x. Okay, that's the first derivative. Now let's do the second derivative. 5 times 30 would be 150. Again, subtract 1 from x, minus 3. And this time, the derivative of cosine is negative sine. So I'm going to write sine. I'm going to change the SIG in sign to plus. Now we find the third derivative. 4 times 150, that's 600. Subtract 1 from the power. And again, derivative of sine is cosine. And so you could just keep going like this. It's just, you can find the derivative once, just keep going until you get to the one they called. By the way, we know that f1 is prime, right? So this 3 would be triple prime, or you could just call it the third derivative, and 2 would be double prime. All right, the last thing is this thing called the linear approximation. So here's an example, and we're going to see this later on in after party. So we have a f of x. We want to find the value of f of 1.1 without a calculator. Okay, that's ridiculous, right? You could do it, but it would be really weird. So what we're going to do instead is we're going to first just find the derivative. You should be really comfortable with this by now. You get 2x minus 11. Then we're going to write the equation of the tangent line at x equals 1. Now remember, you need your x, which we got. We're going to have to find the y, and we're going to have to find the slope. So the y, you always go back to the original. So the y is just plain old f of 1. So that would be 1 squared minus 11 plus 13. Okay, that's 3. Okay, so that's the y value. Slope we get from this middle one, f prime of, again, x equals 1. So 2 times 1 is still 2, minus 11, okay, that's negative 9. So my slope is negative 9. My equation of my tangent line is going to be y minus y equals mx minus x. Alright, now if this is all we were doing, this would be totally fine to stop here. But because I'm going to go and do one more thing, I'm going to go ahead and write the equation of the line but I'm going to add that 3 over so that I get y by itself. Alright, this line is not the same as the curve. However, if I were to draw a picture of a parabola, you could see that they are really similar. So let me change colors here. So there's my parabola. Now here's my tangent line. And that they're intersecting, or they have the shared point right there at x equals 1. If I can figure out the y value of 1.1 on the line, that should be really close to 1.1 on the curve. So instead of plugging 1.1 into something where I'm going to have to square it, I'm going to plug it into a line. Okay, so I'm going to plug it right in here. And this is something you could do without a calculator. AP Test puts this on the non-calculator part, so it's something you should be able to do without a calculator. And I know I'm going through this part fast, but this is all stuff you should be able to do. Okay, 2.1. Now 2.1's on the line, so it's just an estimation for what's on the curve. Let's check the curve and see how close we were. So to actually find f of 1.1, you would plug in 1.1 into the original. And you could use a calculator for this, and you get 2.11, which is actually pretty close.